Hi everybody, it's Mr. O'Connor. I'm going to be out for I don't know how long, so I decided I'd give a try at doing some notes and doing a screen capture. I'll try not to make it too boring for you guys, but here goes. My first attempt at this. So we're going to talk about nitrogen cycle today. And nitrogen cycle is one of those natural cycles that happens in every ecosystem and is happening in your tanks. So we're going to use your tanks as a model for Long Island Sound and the other parts of the ocean where you find the various ecosystems modeled in the classroom. And to understand them, the first thing we need to understand is the nitrogen cycle. So we start off by putting a fish into your tank, and we feed a fish, everybody eats, so everybody poops. And you've got fish that their waste products are coming out in the form of ammonia. And if you've ever smelled ammonia, it smells nasty and bad to us because it's a pretty toxic thing. And as that waste builds up, here's your first fill in the blank that you should be filling in. The process is called ammonification. And that process, ammonia builds up in your tank and can get to the point where it is toxic for the fish that are in there, and they literally poop themselves to death. So this is the biggest mistake, one of the biggest mistakes that people make when they're starting up a new tank. They will plunk a fish in their tank, and it's happy, it's swimming around, they feed it, they want to be nice, so they overfeed it, and those waste products, if they're not being broken down by bacteria immediately, can change the pH of the water, can make the water pretty toxic for the fish to live in. So you need a good colony of bacteria, and the first bacteria are these Nitrosomonas. And without that good colony of bacteria, this fish can't withstand the changes in the environment. Your fish is good for a couple days, flips upside down, floats to the top, bring them back to the store and say you got a defective fish. So you do that again and again because this cycle is just this never-ending cycle of death at that point if you don't have a good colony of bacteria. So the best thing to do is to set up a tank, allow it to run, put some kind of biological material in there, whether it's gravel or an old filter, something that's got some of these bacteria on it, so that it'll establish before you put the fish in. You add one single fish, get it to establish itself and the filtration colonies that are necessary, and then you can start to add other fish. So ammonification is that most dangerous stage at the beginning of a tank. Since you all have tanks that are established, none of you should be in the ammonification stage. We should at least have gotten to the next stage, where the Nitrosomona bacteria break down ammonia into nitrite, which is less toxic, still can end up causing some problems for fish. So that process of breaking down ammonia into nitrite and then eventually nitrate is called nitrification. This is where those nitrites and nitrates are going to build up in your tank. And the group of bacteria that are doing that work is the Nitrobacter. They turn the ammonia into nitrite and then nitrate. And in the process, they are oxidizing it, they're using the energy from those products to basically eat, to feed themselves. And in the process, they produce these waste products of eventually nitrate. Now, nitrate is non-toxic, but in high levels can still cause problems in your tank. Now, in the natural environment, algae would take in nitrates and grow, and then it would go and the fish would eat the algae, poop again, and we'd get this whole enclosed cycle like our one shrimp in the glass ball. But all of our ecosystems are way more complex than that, and as we add more and more organisms to our tank, the balance of nutrients is hard to get the right algae to grow, and to have the right amount of organisms eating it. So instead of that, we end up getting this buildup of excess nitrate, and we hopefully don't get algae growing in our tank. And for us, we're going to remove that nitrate by doing water changes. We remove 20% every month, and the nitrates go down. In nature, algae would grow and get eaten. Now, this nitrate not only gets taken up, but it can get broken down into nitrogen and oxygen gas and released into the environment. Then, if the nitrogen is out in the environment, we need nitrogen to make proteins, and we can't breathe nitrogen in. We have to get it from our food. But there are some organisms that can take nitrogen from the gas and turn it into protein, into food, and that process, is called fixation. So fixation is when algae or bacteria take nitrogen from the air and turn it into protein, which then becomes food for our fish. So all four stages, ammonification, nitrification, denitrification, and fixation, need to happen in an environment for that environment to have a happy, healthy nitrogen cycle. In your tanks, we're going to get these three stages for the most part. Buildup of ammonia, breakdown into nitrogen, removal of nitrogen, and then we don't have organisms that are fixing nitrogen from the environment. So we have to replace that with fish flakes from algae that we either don't want to grow in our tanks or has fixed nitrogen, turned it into protein. They dry it out, put it in a can for us. We buy it, and we feed the fish and make our nitrogen cycle complete in our tank. Okay, so in graphical form, this is what the everything I just said is all summed up. You don't have to memorize these chemical formulas. What you should know, though, is fish waste, poop, and any kind of uneaten food that is going to decompose down the bottom will turn into ammonia, and then nitrite, and then nitrate, and then we're going to remove those nitrates by water changes. And this is the kind of complex interaction where the nitrogen cycle is happening in the environment. You've got organisms at the surface, usually blue-green algae doing fixation. Then you've got ammonia being built up in ammonification with organic nitrogen being produced as poop. Then that gets broken down and the process is nitrification. And then the denitrification is when those nitrogen compounds get turned into nitrogen gas, which floats up and then is taken back in by fixation. That is just a general understanding of how it works in the environment. In your tank, this is what's going to happen. If we had brand new tanks, day 0, you'd start to build up ammonia to about 10 days in. And as the ammonia goes down, the nitrite goes up because the bacteria that are eating ammonia are producing nitrite as a waste product. Then another 10, 15 days, nitrite builds up. It goes down because the second colony that likes to eat nitrites is then going to turn that into nitrate. And then eventually, your tanks, after a month or so, should get down to 0 for ammonia and nitrite and should stay that way unless you have a new fish. Then there's new poop and new ammonia and it starts all over again, but in a shortened cycle. This is a brand new tank without bacteria established in it. Ours is going to be much shorter because we have old tanks with lots and lots of bacteria in them, but your issue is going to be the buildup of nitrates over time. We do a water change and we drop it down and then it keeps building up. We do a water change, drop it down, and it keeps building up. So that is our pattern for the rest of the term. And here's your nitrogen in Long Island Sound if we take a look at this graph and you look at the left side of the graph, this is a healthy Long Island Sound and an unhealthy Long Island Sound on the right side. And the difference here is the amount of nitrogen and phosphorus. And in the marine environment, it's really the nitrogen that is the big problem. With minimal amounts, algae grow, things eat the algae, they grow, and you've got fish that are feeding off of the plankton eating the algae. You have organisms, their sunlight can get through to the submerged aquatic vegetation, eelgrass and seaweed over here. You can get oysters that will filter the water and keep it relatively clear. And actually planting more oysters can make it look like the left side of the diagram rather than the right side because they reduce the nutrients. But if we put extra nutrients into the water, and we do this through our sewage treatment plants, pet waste, fertilizer, manure from farms, all of that runs off into the water and creates an algae bloom that the algae grow really, really quickly, but they die really, really quickly too. And then decomposition takes oxygen out of the water. The algae themselves block the sunlight to everything else on the bottom, and you've got what we call a dead zone with too much nitrogen. This is a huge problem out in the ocean. It has been a big problem in Long Island Sound, but over the last 20 years, efforts in Connecticut and New York are making Long Island Sound look more like the left side now than the right side. And if we get it healthy, Long Island Sound on the left side is worth about $5 billion a year to us, and on the right side, worth nothing. So it's worth the investment to try and reduce those nitrogen inputs. Here is typical break-in in a tank. Day one, fish start producing ammonia, and that keeps going up and up and up until about the end of the first week, and the first stage bacteria start to bring the ammonia down, but nitrite levels go up the second week, and fish can show some distress. Then by the third week, we've got nitrite coming down and nitrate going up, and you start to detect nitrate after a month. And then after that first month, we consider the tank cycled, and it's ready for additional fish to go in. And once you put additional fish in, that means more poop, and you go right back to day one. But since the bacteria are all in there, after a couple days, the levels of ammonia and nitrite come right back down. You might even not notice the levels go up if you've got a healthy enough bacteria colony in there. So that's why we're testing for ammonia, nitrite, and nitrate. And the end.